All right, let's get this started. Did you all have a good weekend? Mom's mom came in? Okay. All right, so here's what we're going to do. I did grade your exams, and what I need you to do is help me out. I'm gonna pass them out to you. Oops, let me silence my phone. I have not put the grades into Canvas yet, so I will need to get these back from you. All right, so let me explain what we're gonna do first. You're gonna get the test, and you are going to start going through it page by page, and you'll see things like -3 circled like that. And then, you keep going, you flip through, and you say -4, whatever it is, right? I need you to add up how many points are being taken off, all right? Once you do that, on the top right corner, you'll put the total. So maybe it's -21. Circle it, put it on the top right corner. Can we all do that? Let's do that first, then I'll tell you how you're going to figure out what your grade is. Bianca, please come grab these. Bianca, Juliana, Nautica, Alex Romero, Robbie, Sean, no. Justin, am I in the right class? Erica Valdez, Jose, Carolina, Lena, DJ, Aspen, Rebecca. You can start tallying up your points. Shivani. Also, there's a bonus question. If it says, like +2, that means you got it right. Just take that and, yeah. Joshua Manning. Catherine Young. Caesar. Bethany. Gerald. Amber. And Daniela. Amber? Right. Daniela. Let's see here. Let's see. Bianca? Got yours here. Okay, so tally up your points. You did yours over there. You did yours early. Did you do yours early? What's your name? You did it here or there? Really? Everyone check to make sure I didn't hand you 2 exams. Did you leave yours over there?
No, I remember I came back.
You brought.
I was going to, but then I was like,
okay. It's probably going to be down in my office. Sorry. You want to after class?
I have no worries about it.
Okay. All right.
I don't.
You took.
Graded either way, so.
You took yours here and turned it in, right? That's really weird. Because I don't see yours in the stack. I'll have to check my office. Seems very strange that there would be 1 exam missing. Let me check my office after class. Sorry. So sorry. Okay, did you tally up your points? Yes? Yeah, so if you have -20 and you got the bonus right, it's -18. Yes. Once you do it and you put the number up there, I want you to go back and do it again. I want you to double check it.
It's the only one I got, and then I
1,
got the
2. So yeah, plus 1 then.
just plus one on top.
Plus 1 on the top. Yep. I'm so sorry. It doesn't happen very often at all.
So what are we doing here?
You're tallying up the points. So keep going. -2, -5, -3 up here. Yep. You don't need to double check that. Everyone have it? Yes? Got it? Okay, so here's an example. There were 13 problems on the test, right? 13 problems. Each one is worth 10 points. So there are 130 possible points. What I need you to do is take your number and basically subtract it from this. So if you got -20, right? You would take away your 20 from this. So everyone's using 130. Take away your points. That would leave 110, right? Yes? Take that 110 and divide it by 1.3. That's the same as dividing it by 130 and then converting it to a percentage. So whatever number you get there is your percent answer, your percent on the test. So this student, if I did this, would be 110 divided by 1.3. This student would have an 84 point, and if you have decimals, just go 2 decimal places, 62. $1.3. Mm-hmm. That's false. Do you remember me drawing the picture in class? You don't remember that? Did you miss a day?
It wasn't called, it was like perspective.
Perspective geometry. You don't remember the road I drew with the buildings? Okay.
It was true.
It was false. Two parallel lines, they can't intersect. I was actually pretty surprised by the number of bus loads of children that went off the cliff. How many people forgot the plus or minus on the square root on one? I think it was problem 10 or something. Was it 10? Yeah. Everybody have it? Okay. What's that? Just put the grade in top right corner underneath, near somewhere there. You can put 84.62%. I'm going to get yours after your class because you had it over there and I didn't get it back until this morning. So let's see. Sean, okay. Here you go. You're going to tally up all the points off.
Okay.
2 minus 1. I'll do it for you. Hold on a second. There you go. Justin? Okay. I didn't have time to put the grades on them, so. Okay. Aspen? Hold on. So make this. Okay, that's. I need it. I'm going to need it back though. Okay, everyone. The other one, it's in my office. Yeah. Okay, I'm giving you some time to look over your stuff unless it's missing, like Jennifer's. I need these back. So at this point, turn them in. I will give those back to you tomorrow after I put the grades into Canvas. All right? Okay. Anyone else?
Put the 10 on the other side, and then you divide by 5.
How is that wrong?
So change it to 2, so it's different squares.
It's supposed to be negative 36.
Really?
Yeah. Yeah, when you get it back tomorrow, you can go back through it. Yeah. You'll have an opportunity to go back and review everything again, okay?
Are you gonna give us any extra credit?
Extra credit for,
To raise my 65
oh. Do well on the next test. Boost your grade.
Because I got the -5. Not choice, I know.
All right, you ready? We're gonna start some new material. I have no idea what to say to you about the test because I don't know what the class average is. I don't know anything. So once I look at everything, we'll talk about the exam next class. All right, so we are going to start polynomial functions and their graphs today. If I can find a decent marker. We only have, what, 2 weeks left? Isn't that nice? We have a test on Thursday, right? We're supposed. Oh, is it Monday? Oh, sorry, Monday. Is it Monday?
I thought it was every Thursday.
I thought it was every Thursday from here on out.
Last Thursday.
This Thursday coming up, and then the following Thursday.
Is that what it is?
That's what it is. Yep.
So we can walk
So,
Thursday instead of
all right.
It's Monday.
Yeah, it's Monday.
It's Monday? Oh, okay. Yeah, it does say Monday. So 2 in 1 week? All right, let's see how things go. We may change that. We may not. Okay. Look at the schedule. All right, so I was looking through the material here that's provided for us and looking at the homework assignments. And I said, you know what? I really don't like any of that. So you are going to do your homework based upon problems that I'm going to give you at the end of class. You're not going to do any of the homework out of the packet for polynomial functions and for rational functions, right? Understand? Okay. All right, so polynomial functions. Let me just start by just asking you to recall that we have actually studied 2 types of functions already in this class. We've studied linear functions and linear functions were something like this: f of x equals mx plus b. It might look a little more familiar to you if I write it this way: y equals mx plus b. And we should all be comfortable graphing a linear function, right? Of course, when we draw them, they're straight lines. And those are good for modeling certain things like someone's hourly pay, or like the guy trying to lose weight in the word problem in the exam, right? It's good when things change at a constant rate. And then we moved on from that and we looked at quadratic functions. And for quadratic functions, they look like this. All quadratics look like that, right? And the graphs of these quadratics could vary a little bit, right? But basically you had a U that opened up or a U that opened down. And I'll just draw one that opens up. And we may or may not have x-intercepts. We might have 2, we might have 1, we might have none, right? And that's what the last 3 problems on the test had to do with. The number 11 and 12 you had to graph, which I was very happy with the graphs. And when I was going through the test, a lot of people got the graphs right. So I was very pleased to see that. And then we did one application of it where we said a falling object on Earth, right? So if Joe's trying to lose weight, he's going to use a linear function to model what's going on. If you're dropping an object on Earth, you're going to use a quadratic function to model what's going on. And then there are different things in the world that require something else, right? And that's where we get to what are called polynomial functions. And the main thing I want you to see from, or learn about polynomial functions is just what they look like, how they behave, what the graphs are like, and then I'm going to try and give you some polynomial functions and ask you to graph them. I'm actually going to also give you some graphs of polynomial functions and ask you to come up with the function. So it's going to go both directions. Everything I've done up to this point, I give you this and I ask you for this, right? Give you this, ask you for this. Now what I'm going to do is give you the polynomial function, ask you for the graph, and then backwards, give you the graph, ask you for the function. Understand? Okay, so let's talk about what a polynomial function is going to look like in terms of f of x. Like, what is it? So I'm going to write this up here. Don't freak out. Let me just write it, okay? Polynomial function look like this. F of x so far, okay? Equals, still good? All right, a subscript n, x to the n plus a subscript n minus 1, x to the n minus 1 plus a subscript n minus 2, x to the n minus 2 plus dot, 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 dot plus a1 x to the 1 plus a sub 0. Now that's ugly, right? Now you can freak out, okay? So this is what a polynomial function looks like, and when you look at it initially, you go, what the hell? This is where math, you look at these math numbers and stuff, none of it makes sense, and you're just like, what is that? Let me give you a specific example of a polynomial function below this, all right? F of x equals 3 x to the 7th plus 4 x to the 5th plus 3 x to the 4th minus x squared plus 7. That is a polynomial function.
Where's your subscript?
Okay, hold on. So, I think above this, what I'm going to do is just put the two things that we had before that we were studying. mx plus b, right? And the other one was ax squared plus bx plus c, right? Those were the linear and quadratic. All right, what was the m here? It was the slope, right? And that was always a number, wasn't it? A number in front of x, 4x, 1/2 x, whatever it was. And then the b here was our y-intercept, right? And that was also a number. So if I filled in these two blanks with numbers, m and b, you would have exactly a line, wouldn't you? It would be a unique line. Yeah? Yes? Okay. With the quadratic, a, b, and c were, again, just numbers, right? If I provided you with an a b, and a c, told you here's a is 2, and b is 5, and c is negative 10, then you would have a specific quadratic function, wouldn't you? So these two functions written like this are what we call their general formulas. As long as someone can provide me with a, b, c, or m and b, I can graph those. But polynomial functions are like a very, very, very large generalization. What we want to do is we want to say, look, I'm going to have a number in front of x. This is a number in front of x raised to a power. Another number in front of x raised to a different power. Notice the powers come down by 1, right? Do you see that? Whatever this is one less power. And then this right here is another number. X, the power comes down again. So do I have a number in front of x to a power? Yes. Do I have a number in front of x to a power? Yes. And that continues the whole way down. Now, I'm trying to answer the question like, where's the subscript? This right here, in our general formula, would be a sub 7. Because this power tells you which number this is. And so you see the highest, if you agree that n is the biggest out of all of these powers, because that's n take away 1, right? This is n take away 2, that'd be smaller. Then this should represent the highest power you see. So x to the seventh means that, look at this as being, this is the 7th coefficient, or this is the coefficient, the number, in front of the 7th power of x. What would this number be right here? And I'm going to include the plus. That would be a sub 5. And what would this number be? A sub 4. And what about this one? It's a negative 1, isn't it? And that right there would be your a sub 2, right? And then what about this number by itself? That's a sub 0. So you notice there's no x's on this last one? That's a sub 0. All right. I'm slowly building to this, all right? You might be asking yourself, well then what's a sub 6? Because it's not on here, right? There's no 6th power, right? There's no x to the 6th power. So what do you think a sub 6 is? A sub 6 is? I heard 1 and 0. What do y'all think? If there was a 1, if I put a 1 in front of x to a power, isn't it just going to be x to the power? But I don't have an x to the 6th. I don't want it there. How can I get rid of something? Multiply it by 0. So what's really here, I think I'll do it up here. If I were to rewrite this polynomial in its most general form, it would actually look like this. 3x to the 7th plus 0x to the 6th plus 4x to the 5th plus 3x to the 4th plus 0x cubed minus x squared plus 0x plus 7. Do you see I've put all the powers of x in there? But there's certain ones that aren't there in this expression, and that's everything that has the 0. And we know that when we multiply by the zeros, it's gone. Do you all see that? Does that make a little more sense? So what is a sub 3? 0, right? So if it's missing a power, then the a subscript there is going to be the number 0. All right. So coming back to these two, I could have very easily said that linear functions, instead of calling it m, I could have called that a sub 1x and then a sub 0. This right here would be a linear function. Do you see the difference? A sub 1 is the number that's in front of the first power of x. A sub 0 is the number that doesn't have a power of x on it. Yeah? But because it's a line, this number is very special to us. It actually represents the slope. So we don't call it a sub 1, we call it m. And then over here, that number is so important because it's a y-intercept, we give it the letter b. Then when we get to this one, the quadratic, I could have written a sub what? Instead of this, a sub what? 2x squared plus a sub, power on the x is 1, a sub 1x plus a sub 0. Do y'all see that?
That's
Yeah.
just like a really complicated formula.
I agree, but there's a reason why, and that's what I'm really trying to get to. Yes?
Never mind.
The reason why?
No, it
Oh.
has nothing to do with the X's, but never mind. I realize what you did.
Okay, so let me, if all of you have that kind of in your head as far as like, okay, there's, you know, what these A's are, they're just numbers, then I want you to be the ultimate, you know, the skeptic here. We have a few skeptics in the class. But Ember is saying it's a complicated way of writing this, right? Let's say I wanted to go from a linear to a quadratic. What would be the next natural thing? You know, highest power of x here is 1. Highest power of x here is 2. The next thing I would have is highest power is 3, right? I could, if I wanted to, say, hey, look, everyone, all third degree, right, third power expressions like that, polynomials, we can write this way: ax cubed plus bx squared plus cx plus d. Couldn't I? I could have walked in here today and said, hey, we did these two, and then here's our new one, right? That's the general way of writing it. And that, I think, would be less complicated, wouldn't it? And then I can say, hey, and if you want to do a fourth degree, then we'll do a x to the fourth plus b x cubed plus cx squared plus dx to the first plus e, right? And I can say, hey, all fourth degree ones will be written that way. Yeah? Yeah, yeah. What's wrong with this? I know this is confusing, all right, maybe because it's so obvious, but why do we as math people not do this and instead use that subscript? A sub 1, or a sub n minus 1. Why do we do that? What do you think? Think about it. There you go. See, you've answered your own question. See, there's nothing that restricts how high this power can go, right? So let me ask you, can you write out for me the general form of a 50th degree polynomial? It would be f of x equals, and then go ahead, try and use your letters, right? Ax to the 50th plus bx to the 49th, and what's going to happen? You're going to run out of letters, aren't you? So instead of saying A, B, C, D, E, I'm just going to call this one A sub 50. It's the 50th number in front, right? It's the number in front of the 50th power. Instead of calling this B, I'm going to call it A sub 49, because it's going to be the number in front of the 49th power of x. And I will never run out of letters this way, right? The subscript allows me to have a polynomial with whatever degree I want. And that's why the general form looks so ugly. It accounts for the restrictions of our alphabet. Got it? All right. Now, with that out of the way, let me show you some examples of polynomial functions and what their graphs look like. All right? So if we take this polynomial function, this is an example of a polynomial function. X to the fourth minus 3x cubed minus 18x squared. Okay. This is a polynomial function because it has powers of x in it, right? All of these powers of x are integers, meaning they are positive integers, non-negative integers. That means the powers are either 0, 1, 2, 3. Okay? If you have negative powers, it's no longer a polynomial at all right? You can't have fractional powers either. If this was like, you know, x to the 1/2, it's no longer a polynomial. What's that? Well, continue taking more classes. Take calculus, so you'll learn how to graph those complicated things, yeah. All right, so we know we have a polynomial, all right? This is polynomial. Check, it's a polynomial. And now I want to talk about something called the degree of the polynomial. The degree is, we use the letter n to represent the degree. And remember in the general formula that I just wrote on the board, n was the highest power of x that you see. So what's the highest power of x we have here? This is a degree 4 polynomial. I also would like to talk about another aspect of this polynomial function, which is called the leading coefficient. and I will abbreviate it LC. And it is equal to the number in front of the highest power of x, which here would be what? 1. This number right here, just that's our LC, our leading coefficient. Now, believe it or not, these two things are going to tell us a lot about what this graph looks like. If you know the degree and you know the leading coefficient, you're going to have two major components of the graph, all right? Two major components are in place. I'll show you how in a minute, but this is just getting some definitions out here for us. All right, what else do we want to talk about? We got the degree and the leading coefficient. Let me go ahead and tell you how we use those, all right? This is called the leading coefficient test. And from here on out, I'll call this LCT, leading coefficient test, all right? So when you hear me say, hey, all you have to do is run the LCT on it, I'm talking about this test right here. So here's how it works. I'm going to make a table so that you'll be able to have this on the test, all right? On the top, we're going to put here degree. And on the side here, we're going to put LC for what? Leading coefficient. So with this degree right here, this number, we know that number has to be 0, 1, 2, 3, 4, 5, 6, 7, 8, right? It can be anything. What we're going to do for this test that we're running is we're just going to determine if this is an even or an odd number. So I'm going to put here even and odd. So we have two scenarios, right? Even or odd. Then we're going to look at the leading coefficient. And the leading coefficient, does that have to be 1, 2, 3, 4, 5, 6, 7, 8? No, you could have like -2. You could have all sorts of numbers in here, right? So what we're going to do here for testing this is test to see whether or not it's positive or negative. That's it. So I'm going to put here a plus sign with the circle around it. That's positive and negative. So do you see that there are 4 possibilities here? We could have an even degree and a positive leading coefficient. We could have an odd degree and a positive leading coefficient, an even degree and a negative leading coefficient, and an odd degree and a negative leading coefficient. Those are the only possibilities. Do you agree there's nothing else that could happen? Okay, so what happens if we have an even degree and a positive leading coefficient? Here's what the graph has to look like. The left side of the graph must go up forever. And the right side of the graph must go up forever. What happens on the inside is still a big question mark. And we'll have to answer that. All right? Just we're not going to be ready to do it yet. The leading coefficient test at least determines what we will call our end behavior. It tells you what's happening at the ends of the graph. What do you think, what does your instinct tell you is going to happen if I keep it an even degree but changing the leading coefficient to a negative? Down and down. That's like a parabola, right? Think about, you've done this already. If I asked you to graph this, if I asked you to graph that, you would say, okay, it's quadratic, right? That's the first thing you would say. And the next thing would be, does it open up or down? And what would you tell me? Because the leading coefficient here would be what? Positive? And since it's a quadratic, that was even. So there's your positive leading coefficient, negative leading coefficient should go like that. And then what about the middle? We don't know, right? Now when it's odd and a positive leading coefficient, it's going to go down on the left, up on the right, and in the middle, again, we still don't know. And then this scenario, odd degree and negative leading coefficient will go up on the left and down on the right, and in the middle, we don't know. So when I give you your homework problems and on the test, you know, the first thing you're going to be doing when someone gives you a polynomial to graph is you're going to be using the leading coefficient test to determine the end behavior. That's your starting point, all right? So if I know what the left and ends of this graph do, then I need to determine this inside piece, right? This question mark. So I'm going to erase this. I'm going to give you a specific example. In this example, can you tell me what the end behavior is of this example? It goes up on the left and up on the right. Yes? So I know when I draw this, it's going to go up here and up here. In the middle, could be doing all sorts of stuff, right? So what do you think I'm going to say we should go try and find next? The x-intercepts, right? Does it hit the x-axis? Right? Does it hit the x-axis? If it hits here, and then it hits here, then I can probably guess that it's going to do something like this and then come back up like that, and I could probably fix it like that. And it would look like that, right? Just, if I had some more points, I could get a better picture, couldn't I? So that's the next step, is to get the x-intercepts. So to find the middle, what I'm referring to here is the question mark right there, right? To figure out what's happening here in the middle, we will find x-intercepts. And how do we find x-intercepts? Set the function equal to 0. It's the same thing you did with the quadratics, right? You set the quadratic equal to 0. What was the good news when we were doing quadratics, though? When you set a quadratic equation equal to 0, when you set a quadratic equal to 0, you always could fall back on what? The quadratic formula, right? Negative b plus or minus square root b squared, all that stuff, and you would always be able to find the x-intercepts. You don't have a formula for a general fourth degree polynomial. And I think I told y'all before that one does not exist for 5 and higher. So we are no longer going to have formulas, which means that I'm going to have to give you very specially tailored made functions that are doable, all right? Or else you'll be in big trouble and you won't be able to do it. So here's what we're going to do for the x-intercepts. Let's go ahead and set this thing equal to 0. X to the fourth minus 3x cubed minus 18x squared, setting that equal to 0. This will tell me, all right, this will tell me if I can figure out what the solutions to this are, where this thing touches the x-axis, right? So, any ideas? Factor, right? Factor. So what's the first technique for factoring? GCF. Do you see a GCF? What is it? X squared. So we pull that out. What will we be left with? X squared minus 3x minus 18. Now, some of you were having trouble doing that on the test. I mean, that's probably going to stick with you. I mean, if you still can't do GCF, that's going to hurt you on this next test. So you want to make sure you're clear on that. Am I done? Can I go further? Yeah, what's in here is a quadratic, right? And we can possibly factor that using the AC method, that little crossy thing, which I'm no longer going to do the work on the side. I'm just going to assume that you could do that, all right? And what would we have in here? What are our two factors in here? X minus 6 and plus 3. So please understand, I am not showing the work to go from here to here. You would have to do that on the side. Two numbers that multiply to be negative 18 and add up to be negative 3. Then you get negative 6 and 3. You do the grouping, the slash, and yes? Okay. All right. At this point, everything is completely factored. X squared, x minus 6, x plus 3. Those are our factors. So like we did before, we just set each of these equal to 0, don't we? Okay, so I'm going to set x squared equal to 0. I'm going to set x minus 6 equal to 0. I'm going to set x plus 3 equal to 0. 3 equal to 0. Let's do these two first. This one is x is equal to negative 3. You just move the 3 over, it becomes negative. This one is x is 6. Because you move the negative 6 over, it becomes positive. So we've got two x-intercepts so far, right? Then what about x squared is 0? You could do square root both sides. What's the square root of 0? 0, right? The only number that you can multiply times itself to get 0 is 0 itself, right? 0 squared is 0. So this is just 0. All right, you ready? We're almost there. We can almost get this graph. What we're going to do now is we are going to start to draw this thing. I know for a fact that I hit at those 3 points, right? So we have 0, we have negative 3, and we have positive 6. Now, I failed to mention this earlier. I should have. So I'll mention it now, and I'll reiterate this later in case you forget. When we do linear functions, they look like straight lines. When we do quadratics, they look like U's, right? All polynomials look like nice, smooth roller coasters, basically. Right? You know what a roller coaster looks like. Woo, you know, something like that. Nice, smooth curves. All polynomials of degree 2 and higher. So when this number is 2 or higher, it's going to look like that. All right? If the degree of the polynomial is a 1, right, the highest power is 1, you're looking at a line. Okay. So with that little image of what this has to look like in mind, let's take a look at what this graph's going to be. I know from the leading coefficient test, the left and right sides go up, right? They go up. So I know that from this point, it has to go up. Why can't it do this and then go up later? I have 2 more x-intercepts, right? And there's only supposed to be 3. So that can't possibly happen. So it's got to at least stay above the x-axis. It's got to be up here somewhere. So I'm just going to kind of very lightly with my pencil just draw in kind of what I know happens there. And then on the other side, I can say the same thing, can't I? This does this. Now, filling in the gaps is the challenging part. And there's going to be an easy way to do it, but I want us to appreciate the challenge of it right now. Just tell me if you think this would work, and don't draw this, all right? Do you think that this would be okay? No? You already said no? Why? Would that picture work? Does it have those 3 x-intercepts? Yes? Does it go up on both sides? Yes, right? That satisfies the condition so far. Let me draw you another variation of this. Could it do this? Does it have this as an x-intercept? That is an x-intercept? That's an x-intercept. It goes up on both sides. Yeah? That would be okay. And I'm out of colors. Do we have any others? What do we have up there? Blue, red. It's green? Go ahead. All right. What about this one? Would that satisfy it? Yeah? All 3 of those are valid. Does anybody see, though, in the blue, the red, and the green, that something is happening, in each one of those, something is happening at least one point. That's a hard way to phrase my question. It's a terrible question. They all have something in common. Let me try and point it out. Let's look at the red one, and I'm going to talk through this. Let's say we're up here on the roller coaster, right? We come down, and we actually cross through the x-axis, don't we? We cross through, and then when we come back up, what do? Do we cross through the x-axis? No, we just kind of what? Just great. We actually, so students sometimes say we bounce off the x-axis, or we just touch it and keep going, right? I like bouncing because, you bounce off. And that's what I like. So we crossed through, then we bounced back down, and then when we got here, we what? Crossed through, right? That's what happens on the red one. So we bounced off of this one. Look at the blue one. We come through, we what? Cross through. Here we cross through, and here we bounce off. So here we bounced off the 6, right? And then look at the green one. We come through and we what? Bounce off, cross, and then cross. So with all of these, there's one bounce, 2 crosses, right? Now, I challenge anyone in the classroom to come up here and draw it a different way. There's no other way to draw this to make the 2 ends go up and to have these 3 x-intercepts without doing 1 bounce and 2 crosses. You have to do 1 bounce and 2 crosses. All right? Well, how do we know where the bounce happens, and how can we determine it? What you do is you come back to this, all right? To nail down which of these it is, blue, green, or red, you have to come back to this, and this tells you everything right here. What is the power on this parenthesis? 1. What's the power on this parenthesis? 1. What's the power on this parenthesis? 2. If the power is an even number, you will bounce off at that point. If the power is an odd number, you will cross through at that point. Got it? So which of those is correct? The red, green, or blue? Red. Because what happens at red? We cross through at -3. Is -3 have a odd power? Yes. What happens at 0? We bounce. At 0, is that even? Yes. And then at 6, the power is odd. We will cross. Understand? This is called the multiplicity test. These powers are called multiplicities, and that's the way we're going to be able to graph it. So let me put my final version of my graph in here for you. And then what we're going to do is we're going to start a whole new problem all over, and we're going to run through everything in the proper order. All right? This was just to get us to see how this is all going to come to life. You all are like, I don't know, y'all okay? It's Monday, I guess that's what it is. All right, so I'm supposed to cross through here, bounce off, and then go through like that. That is the correct graph of that polynomial function. Now, I can tell you right now that if you get on your graphing calculator and you type it in, it's going to look a little different. And that's because what I don't know is how low this point goes. And I don't know how low this point goes, like in here. I can't tell you how low those go. So somebody else might draw the same picture, and the answer would be 100% correct if they drew this instead. Okay? That would be a correct answer on a test. Because none of us in here, from what we're learning, can determine how low these go. Guess where you would actually go and figure that out? Guess what class you go figure out how low these go in? Calculus 1. All right? And you do it for general polynomials. See, if you have a quadratic, right, x squared, don't we know the lowest point? It's the vertex, and there's a special formula for it, right? H is -b over 2a, that thing. That formula comes from calculus. It's actually a very simple result in calculus to show that. But in general, it's a little harder. So we save it for later. All right, let's start with a brand new fresh problem. And this would be a good example of what you're going to be taking home to do, and a good example of what you would see on a test. All right? Here we go. So the instructions here are to sketch the following polynomial function. Let's go x to the fourth. Let's make it x cubed, sorry. X cubed plus 4x squared plus 4x. And I think before I graph this, just think about the stock market, right? Stock market has, daily it's doing all sorts of things like up and down. That's not linear. It's not a parabola. But you could probably model it with a polynomial better than anything else because it looks more like a roller coaster. Just trying to get some idea of like, well, where are you going to see polynomial functions, right? All right, what's first? What's the first step? What do you think my first step's going to be? Is it a polynomial? Yes, it is. Now, I'm asking myself that question because when I get to the final exam and I'm asked to sketch something, if it's a line, I'm going to do a certain thing. If it's a quadratic, I'm going to do something else. And if it's a polynomial, I'm going to do this, right? So you always want to recognize what it is you're looking at first. Next thing. Let's do the LCT, that leading coefficient test. Now, to do the test, I need two things. I need to write down what the degree is. The degree here is what? 3. And what are you concerned about when it comes to degree? Are you looking to see if it's positive or negative, or even or odd? With degree, it's just even or odd. That's what you want to know. Odd. My D's and O's look the same. Okay. The other thing, leading coefficient. What is the leading coefficient? 1 again, right? 1. It's the number in front of the highest power of x. And what are we concerned about here? Even, odd, positive, negative. Positive or negative. And this one is positive. So now you're able to go to that table, which you would have on the test, right? And you're able to tell me what the end behavior is. So I'm just going to draw it real quick. What is the end behavior? Left side does down and right side is up. Okay, so it's down, question mark, up. I know that much so far. And that is actually critical information, all right? We have to have that to continue. What comes next? Let's get those x-intercepts, right? Let's get those x-intercepts. So we're going to set this thing equal to 0. Notice that I didn't get the y-intercept. Did y'all notice that? You don't need to do y-intercepts on polynomials, all right? X-intercept, we're going to set this thing equal to 0, and then it's factor time. What do you see? GCF of x, good. So pull that out. You're left with x squared plus 4x plus 4 equals 0. And if you do your factoring on this one, so dot, 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 you do the work here, you would determine that this is x plus 2 times x plus 2. It'd be x plus 2 times itself. You'd have the same factor twice. Is that all right to leave you with that on your own? But x plus 2 times x plus 2 is the same as what? X plus 2. squared. Now, why is that important that I recognize that? That number is what we call the multiplicity, and if that number is even, I'm going to do what? I'm going to bounce at this factor, and if it's odd, I'm going to cross. What is the multiplicity of this factor? 1, because there's a little power of 1 on those. Got that? You sure? Now, you still have to set these equal to 0. All right? But I'm going to put a little note in here. At this point right now, because this is 2, because this is even, I'm going to bounce here. And this right here being odd, I'm going to cross. But I still have to set them to 0. So this one, x is 0. That's pretty simple. That's done, isn't it? You set x equal to 0, it's 0. And this one right here, you set this to 0. X plus 2 equals 0. You get x is negative 2, right? With me? The mistake that I see people make is that when they're trying to determine bouncing and crossing, they look at this number and say, oh, is that even or odd? Is that even or odd? And that's not what you look at to determine the crossing and bouncing. It's the power on the factor that's important. We all good? That's it. Draw it. Let's do it. There's only one correct way to draw it. Of course, we are waving our hands at the idea that we won't know how low things go and how high they go, but we will know where it crosses, where it touches, and what the end behavior is. All right, so I'm going to start with the x-intercepts. Always start by drawing your x-intercepts. They are at 0 and at negative 2. Got it? Now what I'm going to use is the end behavior. The left and right behavior. What do I know happens on the left side? Goes down. So from this point I have to go down, don't I? And on the right side I've got to go up. Now I'm not going to put them there yet. Or if I do, I'm going to do it very lightly. Okay? Because if I'm going to come down this way, like this, and from this point I've got to go up like this, I also have to think about what I'm doing at each of these once I get to them. So when I get to negative 2, am I supposed to cross through or am I supposed to bounce off? At negative 2, I'm supposed to bounce. So I'm actually going to bounce off that, and then I've got to get back to this point, right? Because this is like connect the dots. So I'm actually going to write this in nice now. I'm going to come up here, I'm going to bounce off. Notice it's curved, it's not a V. I think there were 2 people that drew their parabolas and they looked like V's on the test. Not V's, curved. Okay? Once I come down, how far do I go down? It doesn't matter, okay? But don't go above the x-axis, all right? Just stay below. And then once I get back to this point, which is 0, I'm supposed to what? Cross through there? And you can see it's going to be a natural flow of my drawing motion here to cross through and go up. That's it. That's the sketch. Okay? So I'm going to give you one now, and you're going to do it on your own. Actually, I'm going to give you a few. So I want you to sketch the following. First problem.